Good morning and welcome to another video cast from Hendy Consulting, the specialist management consulting firm to the $120 billion FPD display market. And today we'd like to do a little bit of scenario-based thinking about the future industry structure of the micro-LED industry. And that's really because that's really not a set thing yet today. There still are chances that it will emerge in a different format to the current one that it's in. And in fact, the current one is industry structure isn't actually what the rest of the display industry has. So that's interesting even of itself. So we'd like to build on top of some of the great thinking from Joel and Eric on industry structures for micro-LED, but then also put our own points of view on which we think will emerge and under which circumstances and which part of the market. So we're going to talk about at least 5 different structures and what will cause them to emerge in the display industry, along with winners and losers in each case. So actually the current market structure is number one, where you've actually got the two brands, Apple and Samsung, defining the value chains. Samsung for the wall and Apple for watch, and they are brand-centric value chains, which is actually pretty unusual. Most of the rest of the display industry is display module-centric, and the display players control at least the architecture and what's being produced. And actually, in micro-LED, we've got something other than that. We've got Apple trying to be almost vertically integrated, or at least to a degree. They are sort of defining their whole value chain for the watch product. And then Samsung, that's actually doing assembly in Vietnam, and that's actually the TV brand business within Samsung and not the display company themselves. So that's actually very unusual. Model 2 is then the more likely, I think, 3 to 5 year model, which is display-centric value chain. And then we discussed 3 others. One is based on micro ICs, which again is a architecture that Apple has been claimed to be using small little micro ICs with many legs that drive many pixels on a display instead of TFTs. There have been some that claim that you can actually do more with CMOS in terms of image processing, and hence more with micro ICs than you can with relatively limited pulse width modulation and pulse amplitude modulation for TFTs. Then we talk about Smart Pixel, which is about taking that one level further, where you actually then have small packages of RGB dyes along with sensing, the driving and other functionality all on a very small little platform that you can then place. And then of course there are many fewer placements if you go that way. But it's a semiconductor centric model where the value is mostly then captured by the semiconductor company or by the architect who, XDC is the most famous here. And then finally, we want to talk about wafer-to-wafer bonding, which is for non-direct view displays, and companies like MicroLED, but others looking at purely semiconductor processes for wafer-to-wafer bonding for microdisplays. So the first model, and as I said, it's actually somewhat unusual because the OEM brands are the ones in the driving seat. So Apple for the watch display and Samsung for the wall display. And that's actually unusual in that the display players don't play a massive role. There actually has been some rumour recently that LGD is also involved in the Apple supply chain, and it's not exactly clear to me how yet, because again, this discussion about whether TFT is the driver for the micro LEDs in the wall or in the watch product, or whether they're using micro ICs, and that's not clear yet. But anyway, the current model has the 2 big brand companies leading the value chains, and that's actually fairly unusual. But it's and it puts the display companies a little bit on a back foot in terms of their role in this space. The one that I think is more likely to emerge as a 3 to 5 year outlook is the display companies back in the driving role, defining a display and putting it off at high pixels on and with very high yields. That's precisely the role of the display companies, and so companies like AUO and Innolux, but then the 2 Koreans probably also, and maybe Tianma, getting involved in defining displays for micro-LED displays. This is the sort of more known model, and I think Model 1 may flip to Model 2 over time, and there's probably quite a bit of politics inside the Samsung company about making that happen between SEC and SDC, I would have thought. But then there's the question about whether actually TFT driving is sufficient, and whether actually what we need is micro ICs, because they allow for simply a greater amount of signal processing on CMOS than you would be allowed for even with 24 mask LTPS for pulse width and pulse amplitude modulation. And so then this might actually give more value to the fabless designers of the micro ICs and or TSMC and is simply a different model than the display industry is used to, you'd also have to have somebody providing some sort of semi-dumb substrate to the whole thing, because now all of the value and the functionality is in the micro ICs and the MicroLEDs themselves, and the backplane becomes relatively value less. And so then somebody's got to provide that, be it on PCB board or be it on some sort of other substrate, some sort of glass. Somebody has got to provide the metal line traces at scale to go do this. And I guess my belief in this happening is if there was really a benefit, firstly, in the additional signal processing capable with micro ICs, and you have to assume in this model that TFTs fail, or at least largely fail, to be able to produce a good enough image, and that somebody else will step in and provide the semi-dumb substrates to allow this model to emerge. So there are several things that need to happen for this one to come off. But people have said that Apple is going down the micro IC route, and we will find out as we get closer to the beginning of 2025 launch. Then Smart Pixel goes up one level again, and there have been multiple companies advocating this sort of type of architecture, most notably XDC in the US, where you could actually put down an RGB package on a small piece of CMOS, where you've then got the driving functionality and potentially additional sensing and other functionality built into it too. Certainly you'd end up with a smaller number of mass transfers, but it's a semiconductor value centric model where the winners are the semiconductor players and or XDC. XDC actually provides a backbone where you can actually pick and choose across the elements of their IP and services they provide in terms of providing some of these things. But it really needs a catalyzing major company to pursue this and make a really big win with it, to make everybody think again about this. And again, you've got relatively dumb substrates, so the display industry themselves may not be that keen on this model, but the semiconductor industry might be very keen on this model. And then you could also talk about wafer-to-wafer bonding, and that's certainly part of the marketplace for non-direct view small micro displays. And what's really interesting about this is that the display industry here is pretty much shut out. It's almost a semiconductor only sort of wafer scale business, and that's what makes it fascinating to me. It's a completely different culture and set of tools, set of thinking that's being used here. You certainly got to do wafer size matching between the back plane and the front plane, and interconnects, and all of the challenges that go along with that, and certainly some of these firms have been working on that. But my feeling is this is a part of the market for non-direct view displays. So then you've got at least 5 scenarios, and my point was that this isn't done and dusted yet. At the moment, option 1 is actually the one that's the major model, and it's actually pretty unusual in that that's not the model adopted by the rest of the display market, which is actually the second one. And I have this strong belief that it will migrate from 1 to 2 just because of the competencies you need to pull off displays of this complexity in general. But let's see whether that happens. There are then very real questions about whether TFT is actually sufficient and whether or not you get greater degrees of freedom using micro ICs or smart pixels to drive these displays. And certainly if people can manage to demonstrate the upside and the benefit of such models, and maybe Apple will, then you've got increasing chances that people will consider micro IC or smart pixel centric models. And then finally you've got wafer centric wafer to wafer bonding models, which to me is for the micro display space, for non-direct view displays, but it certainly could be part of the marketplace. Finally, then we're going to talk a little bit about Henley Consulting before we sign off. And we're a management consulting company as opposed to being a market research firm. And we answer sort of questions like, is the technology that I have any good? How do I set up a joint development agreement with the display industry? Should I build a factory for this technology? And how can I increase my chances of success? So those are simply different questions to those of the major established market research firms. To my YouTube audience, I hope you like this video. There are now 40 something plus other videos on my profile, and I really hope that you'd be interested in looking out at those. We cover topics from profiles of the major players to a number of how-tos on how to be successful in the display marketplace, with some outlooks also on technology and government industrial policy. So I hope you find that interesting. Thanks very much. Goodbye.